Alright, Math 2, we're going to go over law of cosines real quick. We did law of sines yesterday, and this is going to be our third law. We got our right triangle trig, we've got our law of sines, and now our law of cosines. As you can see, because there are three different angles and three different sides, it looks like there's three different formulas, but if you look carefully, there's a pattern to them. So it's always A and big A. Notice it's always, the side you want is always opposite of the angle that you have. So for the B squared and the B and the B. See, they're always opposite. So that's going to be an important part as we label our triangles. Alright, I'm just going to use this first one as often as I can. So that's what I'm going to memorize. And since this triangle looks a lot like this triangle, I'm going to label it very similarly. Okay? Brand new formula, so I'm going to write it down. Always a good step to do anytime you're using a brand new formula. And because it's the first time I've used this, I'm going to even leave all the blanks. Remember, we're going to plug in and fill in these blanks for this formula. So I'm going to make sure I know where everything goes. So I don't know my A, that's what I'm finding. So I'm going to put my B right here. B is obviously the 12. C is 10. Let's see where I put all those in. Now at this point, I just want to take my time and be very careful with my computations. Now the good news is with the law of cosines, if you're trying to find a side like a squared, I can actually put all of this in my calculator at one time. Okay, now I'm not going to do that on this example, but you can do that. So you can tell I'm going to take my time here. And again, you can see right here, you can put all of that in your calculator at one time. You will end up with about 26.5, but that's for a squared. So of course, if I square root both sides, a is going to be about 5.1. Okay. Now for this particular problem, the perimeter, of course, you add up all the sides. But the important part of this wasn't the perimeter. The important part was using the law of cosines. All right. We'll try another example, very similar. Before I can get into this example on the left with the hiker, I have to understand the directions. I need an angle that's missing. So they tell me that I've got a hiker 5 miles 15 degrees west of south and 7 miles 25 degrees east of south. So I need to understand west of south and east of south. Okay, if south is down, then 15 degrees west of south would be to the left. So that's up in this little corner right here. Right? And 7 miles 25 degrees east of south, that would be the other direction. So that puts that up there. So really that tells me that that big angle up there is 40 degrees. So I'm going to label my triangle with my little a here since I'm trying to use the first formula. B and C. And then of course copy down my formula because it's the second time I've ever used it. Alright, take your time filling in all the blanks. Make sure you put everything in the right spot. Alright, and at this point, once again, I remind you that because I'm solving for the side, I can put all of this in my calculator at once. And I end up with 20.6. And then to square root those two, I would find out that A is about 4.5. So the waterfall and the camp are about 4.5 miles away from each other. Take your time going through this. Really take your time putting all of this line in the calculator at one time. Now, this next example is going to be our hardest example with the law of cosines. Notice on the other two examples, what they gave me was, I'm going to back up here. What they gave me was, I'll get this right in a second. What I was going to point out on the other two triangles is what they gave me was side, angle, side. And it was true on the other triangle as well. But if you'll notice on this particular triangle, they gave me side, side, side. Side, 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 the only situation where you have to find the angle and you have to use the law of cosine. So this is really, out of our three different methods, this is really probably the trickiest method of them all. let's see what it's going to look like. Of course, fill in your blanks. Now notice this time, a is my variable. I know little a, I don't know angle a. And here's a good place to stop. Now, before, I was able to put all of this in my calculator at once. Well, I am not able to do that now. Now I have to follow the order of operations very strictly. I can add the 36 and 25. And then this becomes very important. 61 and 60 cosine A are not like terms. And you are not allowed to subtract those. Probably the number one mistake that happens with the law of cosines. You cannot put those two together right there. So instead, I have to subtract the 61. And now I can divide by negative 60. And that leads me to this situation here where I know the cosine of my angle is equal to 0.95. If you remember, to find the angle, you're going to do the inverse cosine of both sides, because the inverse cosine and the cosine will cancel. And come up with 18.2 degrees. All right. The trickiest situation here. Now, of course, the answer to my question is, will my given ramp work? Yes, my given ramp will work. But the important part here was being able to run through this. The law of cosines, take your time with it. Tonight's problems are very straightforward, but do take your time and be careful with your computations.